Good afternoon, everyone. Okay, 1 minute. Let me open my PPT. Okay, it's 6-1. We'll wait for 5 minutes, then we'll start the class. Hopefully, okay, one thing. Hopefully, I'm audible to everyone. 6-1. Okay, I think I should start the class. Then, if you join, because class is from 6. First, I will. 1 minute. Sorry, I think I did some mistake. Uh, okay, let's begin the class. Okay. First question today we'll solve that we'll calculate the change of entropy. I am giving one system, one pathway, and we'll calculate the change of entropy. This is not a mathematical question. This is based on theory. This one pathway and this is another pathway. This for another pathway, this the entropy change is del S, and two it is divided by two pathway. When then first step is del S1, second step is del S2. So we have to uh, derive the relation between del S and del S1, del S2. And del S for del S1 and del S2, which one bigger, larger? These two are first. what do you know about entropy? Here we can see how we'll solve this problem. When this type of problem will come, first we have to think they are giving two pathways. So when they are telling you pathway, then we have to think that we all know that there is a term state function and the path function. So if the path, if it is a state function, then it doesn't depend on the means pathway or process in which way it is going. If you think it starts from A, it will go from to B. Whether it will follow this pathway or this pathway or this pathway, it doesn't depend here. A, B, C. All the case, if it is a state function, then A prime equals to B prime equals to C prime. Okay, so here we sir already discussed all these things to you. If it is a state function, first of this is entropy is a state function. Okay, entropy is a state function. So del S will be del S plus, sorry, del S1 plus del S2. This 1, 2 they told to derive the relation. So this is the only theoretical question. Okay. Another they want to tell the del S2 which one was the larger. So entropy is for reversible system. Q reversible by T. So first del S1 Q reversible, if we think that T and it, so if we constant the Q equivalent, then it is inversely proportional with the temperature. So first one will be 25 degrees centigrade. Del S2 will be by 50 degrees centigrade. So which one? It is greater. So del S2 will be lesser. It is lesser. It will be greater. So del S1 greater than del S2. This one the relation between del S1 and del S2. Hopefully it is clear to everyone. If you have any doubt, you can ask me here. So I am moving to my next question. As no one is asking anything, so one will calculate the work, how much done by the system or is done to the system. So I am giving one pathway P versus A, B, C. So I am giving the values, okay, 5, 1, 5. Okay, this is in bar, sorry, it is in liter and this is in bar. Okay, so now how we will solve this question? Okay, let's choose the. So how we will look the question? Okay, first if you see A to B work, we'll calculate the work done. If A to B pathway work done, A to B, what is the expression? Minus PdV. So we have to del V. Here, if you see here, there is volume is constant. There is no change in volume if you go from A to B. So del V is 0 here. Del V equals to 0. So work done equals to 0 for AB pathway. This one for the first one. And for the second one, from B to C. So first of all, this is very important, whether it is reversible or not reversible. So if it is a irreversible pathway, then we have to calculate this is the del V equals to del V means V2 minus V1. Okay, here for it is for irreversible. Pressure 1, T2 means 5 minus 1, this one for liter. Okay, minus 1 means 4 bar liter. For irreversible case. For reversible, what is the equation? Okay, let's derive. PV equal to N and T. This is for ideal gas. L and B. Okay. So now we have to integrate from, okay. So what is the Ln to Ln V2 by V1? Now we will put the values. This is, they gave the 1 mole, R value 8.314 joule Kelvin inverse, mole inverse. Okay, the temperature is 298 Kelvin, or Ln V2 minus V1 5 by 1 liter gone. Okay, equals to minus 2 Kelvin. Joule mole inverse. Okay, this is for reversible case. Hopefully everyone got it. If you don't get it, then you can ask me. Otherwise, I will move in my way. I will think that everyone will understanding that. Now, next question is, okay. I will providing the question. Okay. First, these all are the from competitive exam questions. So, okay, let's, okay, 1 minute. Okay. First, I will write the question. Ideal gas. So, 280. Okay, first I will write the question and discuss. Okay, 262. Sorry, 600 Kelvin, 480. Okay, now first, how to solve this question? Sorry. First, what are the things they provided? Mole, 1 mole. For solving any kind of question, first you have to write what the things they have given. Okay, T1 300 Kelvin, P1 280 T2 600 Kelvin, P2 480. Okay, these things are provided. They told you to calculate the entropy change for the process. So I am writing the equation which for entropy change. So it's like that ncp bar ln t2 by t1. If I don't know this, please check sir's lectures, and otherwise you can ask me. I can give you the from where you get to know. Or if you go through the lectures, you will easily solve it. Okay, they told it that this is a CP bar term is there, so we have to calculate the CP bar. They told this is a monoatomic gas. For monoatomic gas, CP equals to CP bar equals to C by 2R. Because CP bar calculation, we have to calculate this translational, rotational, vibration, and electronic. And for monoatomic molecules, these things are not there. So only contribution is from the translation. So this is the rough part. So CP bar will be C by 2R. So CP bar minus CP bar equals to R. So what is the value of CP bar? R plus CP bar. Okay. So it will be 5 by 2R. CP bar we got. So other things I think we already have N1, T1, T2, P1 and P2. Okay, now I will just put the values here and we'll get the answer. But we'll put in with 3 by 2. Sorry. Let me write from the beginning. 1 mole. N equals to 1 mole. CP bar equals to 5 by 2. R, okay, let me write it here first. T2, T2 by T1 minus 1 mole. Okay, 1 mole ln T2 by T1 means 600 divided by 300 Kelvin 1. Eight point three one four. P2 will be 2 atm. P1 will be, sorry, P2, what was the value? P2 4 atm, no? So P2 4 atm, it will be 2 atm. P1 2 atm. I am just putting the values, okay? So mole cancel. Okay, other things, rest the things. Ln 2. This will be 2. Sorry. Minus 8.314 ln 2. So next I will move. So I am just 5 by 2 minus 1. Okay, this one 8.314 ln 2. I am just, these two are common, so I am taking these things in one side. Okay, this one will be joule Kelvin inverse 3 by 2. 8.314 into ln 2. This one will be the value. Okay, or 3 by 2 r ln 2. You please calculate the value and that will be the answer. Did everyone got the, everyone is getting or not? Oh, sorry, I think my 1 minute, okay? Sorry. Well, I didn't have chance. Okay. So we'll see our next question. Today I'll end the class a little bit early, okay? Because okay, I have some work. So, but if you have any question, you can ask me because otherwise it's fine. Okay. Then another question is the difference between the standard molar entropies. Okay, I write the question. We have to calculate. They provided that MA equals to 2 MB. Okay. Now first, what we'll do? First, we'll write what they provided. Then if you do, then you see the automatically your mind will go. Means how you will solve this thing. What things they only provided 2 MB. Okay. And they told to calculate del M is 0. This calculator. Okay. So what? So they to only gave mass. So we have to calculate. This is the equation I am providing. Okay. Actually this question came in the competitive exam. So I gave this question. But if you don't know the equation, you may not know. But if you don't know the equation, then please tell me. I will share the corresponding link where you can go through the report. Okay, this is the general equation. Okay, this is the now we have to calculate from MA. So 3 by 2 ln. So sorry. This is for this is the general equation. P by P0 for MA and for M B molecule. What will be the expression? 154. Okay, this is the expression. Only what the difference is there, they told that there is only difference of the value of the mass. Okay, so I've just only other things the same. Given temperature, they were told given temperature means at a constant temperature, and they didn't other things also they did a standard molar entropy also, and these things are this is the standard means at ideal condition standard pressure 1 atm. They also means these two are same for this case. So these things will go out because these two are same. This is the general equation I told na. So as this is the sorry this is the expression this is when S 0 then this P and this P0 will be the same. So it will be 1. ln 1 means 0. This thing will go out. So these things are same both the cases as they told this is at the given temperature. This is very important what I told you now. Here, okay, I am writing it here. Here P equals to P0 as standard state. So ln P0 by P0 equals to ln 1 equals to ln 0. So these terms will go out. only this term will left. Among them, these two are same, as they told they are in the same temperature. Okay, so only these things are the variable. So how to write the difference? Sorry, I have to add slides. Okay, so where are we? Okay, we have to calculate del S. Del S here 0 MB. They told to calculate this thing. Okay, the question was that you calculated del minus. Okay, okay. I think this one A. They told to calculate A minus B. Means for A molecule and for standard entropy, molar entropy of the A molecule and standard molar entropy of the B molecule. This that difference they told to calculate. So now I will just put the values because these things will go out. And okay, I'll put then I think that will be minus 1.154 MB. So what the things are there? These things all go. Okay. Now we'll just put the value they already provided. MB. Okay, then I just put the value of MA. Okay. Okay. This is the expression. And this will be the answer. Now I'm moving my next question. Hopefully it is understood to everyone. This is different kind of questions, but it also came in the CSN net. Okay, first I'm giving you the question. When uh, 2 moles of the liquid A are mixed. I will elaborate what the things they want to let me write the question. They told to calculate the G mix kilojoule. Okay, okay. First thing, how to approach the question. How to approach it? First, they provided G mix. G mix they provided. Okay, the LG mix in the liquid state. This is very important. What they provided, I am just first writing it. Okay, they told to calculate in kilojoules. So this is per mole. So what the moles? 2 moles of A and 2 moles of B. So what is the total mole? 4 moles are there. 1.5 kilojoule into 4. mole into this one mole into, so this 2 minus 1.5 into 4 kilojoules. Okay, 1. Okay, what the things they asked, excess molar gives free energy. Okay, so okay, first I just want to tell you something. Means when means we dissolve from gaseous state, means we gaseous state del G and the liquid state del G are completely different. Means, okay, let me tell you something. So, when a molecule in the gas phase, when it shows that type of mixing, when it comes in the solution phase, so when the what the other things uh, we have to take the consideration that the thing is the solvation energy. Okay, so first the when the molecule in the gaseous phase, if we consider the energy of the molecule is G gaseous, that plus have to be solvation energy that will give the gives free energy in the liquid phase. Okay, because solvation energy when molecule in dissolves, we dissolve the molecule and we come in the solution phase, it the solvation energy it has to be added. So so these things they told that excess molar gives energy. What is the excess molar gives energy? The excess molar gives energy is the difference between the when the reaction in the gaseous state minus when the reaction is the liquid state. Okay. So here they told to calculate the reaction solution. Del G mix for the reaction. Means they told to calculate this thing. Okay, so sorry, let me add one more slide. So what will be the value? Del G R mix will be del G E excess what they provided plus del G L mix. These things is not provided, we have to calculate. So how to calculate the del G liquid mix? There is equation. The equation I am writing. If you because equation I can't derive here. Equation you have to go through the lectures. Then you can write these equations. For total mole R I am putting the value. Temperature is given. What is the temperature? 300 Kelvin. They given the temperature. Okay. And we have to calculate the x1 and x1. N1 by N1 plus N2. X2 equals to N2 by N1 plus N2. So N1, N2 they provided. N1, N2 both they provided. This will be 2 mole. So what is the value of x1? 2 divided by 2 plus 2 means 1 by 2. X2 will be this. So now I will just, sorry, this the summation means these two values have to put. So half ln half plus half ln half. This is the summation. Summation for two liquids are there, na? For x1 for the first liquid, A liquid, and x2 will be the second liquid. Okay. So what will be the value? Okay, sorry, this one will be plus 4 into 8.314 ln 2. This minus will come. This one will be the joule. So what will be the value? Please calculate it by yourself. But okay. So this one will be the answer. This you have to solve means I wrote everything. You just put it in calculator, or then the calculator. This one will be the value. I'm provided you the values. Okay, and I solved it one by one. Okay. I think I today I want to finish little bit early. I have a little work for that, so um, let me save the file first. Okay, okay. I think today I should stop the class here. So, but I have solved 5 or 6 questions. You please go through that, and if you have any question, you can ask me, or if you can bring some doubts or bring some question, we can solve it here. Okay, okay. If you have no question, then we'll end the class for today because I have little work for today. Okay. If you ask, if your questions are always available because this is for only for you people, so that you can solve your question here. Because it will be better if you give your questions here, and I'll talk to sir and discuss about the questions, and we'll solve one by one. If I can't directly means can't solve it in that same day, I will mail you, or I will solve that question in the next class, and I think that will be helpful for all of you and for me also. Okay, let's end the class for today here. If you have any doubt, you can post, or I will solve them and let you know in the next class. Okay, hopefully. Okay, thank you everyone. Okay, we'll meet in the next class. Okay, thank you. Bye.